Hello, let's get started. Welcome everyone. Good afternoon, good evening, good morning. Welcome to our talk, Keeping Adobe Commerce Live Search Results Fresh in Real Time. My name is Charles Katili. I'm a software engineer, joined Adobe about 3 years ago.
I'm Bill Coulter. I'm a lead at Adobe, and I've been with the company for about 3 years too.
Yep. So both of us are going to present this talk. Let's get started. Here's the outline of our talk. I'm going to cover background and compare native search versus live search. Going to discuss indexing challenges and document structure. And Bill is going to cover full indexing, streaming architecture, also performance, scalability, and future work. A little bit of background for everyone that Magento is currently known. Adobe Commerce is a open source e-commerce platform, completely extensible by merchant consultant. One can modify Magento source code itself. Merchant has the option to have it hosted or on-premise options. And in a hosted environment, one cannot control deployment spec. For example, changing Elasticsearch cluster size or instance type, etc. And it does come with the default Magento native search capability using on-premise Elasticsearch. And in the recent years, we have been building towards composable commerce. The first offering was product recommendations. It was released January 2020. While building that product, we were also building a couple of foundational services, such as catalog service and merchant review service. And LiveSearch built on top of these foundational services. So take advantage of this catalog service on the SaaS side. And the second offering, and the one that we are going to focus on today, is LiveSearch. It was released 3 months ago. And this talk specifically is going to talk about how we're going to keep the data for LiveSearch to query fresh. Here's a little bit of comparison between native search versus LiveSearch. So as far as the model, native search is on-premise, hosted, while LiveSearch is multi-tenant SaaS. And the release cycle is also different. Native search, the release cycle is somewhat slower, only twice every quarter, while LiveSearch, this year alone, we already deployed more than 125 times to our SaaS environment. Cost-wise, native search, it can be pricey because Elasticsearch is needed per Magento instance, while LiveSearch is multi-tenant, as I mentioned, so it has that economics of scale. Search performance-wise, native search can be up to seconds, while in LiveSearch, we have our internal SLA. We try to keep it under 200 milliseconds or less. Feature-wise, native search missing some popular e-commerce features such as merchandising control, search as you type. We also have Adobe Sensei providing intelligent faceting on the LiveSearch side. Support-wise, native search does not have a dedicated search-specific team, while LiveSearch has its own dedicated team, managing its health, capacity, indexing, relevancy, and performance. Industry rating, native search received score 3 out of 5 in 2020. LiveSearch is still TBD because it just got GA 3 months ago. So there's a little bit of comparison between native search versus LiveSearch as a SaaS product. So now we're getting into a discussion about the indexing challenges. On Adobe Commerce Magento catalog, there are different type of product types. There's a simple product where you can think of like gift card, virtual product, downloadable. Standalone product is a simple product, but there's also a configurable product. You can think of a configurable product as a product that comes with variants. So an example is that a pen may come in different sizes and or colors. And a configurable product may have 1 through n child products. And a child product is basically a different variants of configurable product. So a pen may comes in blue color, size 34, black color, size 32, so on and so forth. And a child product on its own may or may not be feasible when user search the products. Because all of these different product types, we need to ensure that when LiveSearch scoring variety of product types, it can represent the result properly. What I mean by that is that, for example, here, that if I'm querying pants, for example, it returns 26 results. I know it's unclear here from the screenshot, but these results do not count the child products necessarily. So we can look at the facet on the left-hand side here. There's a categories, price, size. On the price faceting, right, the counts are exactly what you expect, that there should be 26 products. But under size here, notice here the size, for example, size 28, 29, so on and so forth. There are 13, 12, and 12. You might be wondering, well, why they're not adding up to 26? Because, you know, a configurable product, right, may have one or more child products, so that LiveSearch is able to perform faceting or aggregation across child product when the result being returned not necessarily has or contain the child product. So that's what this is showing. LiveSearch is also able to return relevant child product data. What I mean by that is that, you know, when user querying, for example, pan, red in this case, LiveSearch is able to return information about relevant child data. So a configurable product may have a default image, for example, a black pan, but in this case, LiveSearch is able to return a child image, which is red pan, which is part of this configurable product. Another indexing challenges is that within Magento, it has a concept of attribute metadata. So there's no single merchant indices that look exactly the same like other merchants. So this table provide a contrast here that, for example, if we have 3 merchants, a wine merchant, a car parts merchant, a beer merchant, right? Each of these merchants may configure their index differently. That they're searchable maybe for the wine merchant, it may want to search by year, appellation, wine type, while a car parts merchant, for example, may want to search by manufacturer, model, while a beer merchant may want to search some attributes of the product, right, such as brewing extract, yeast type, so on and so forth. Filterable inserts, which is for faceting here, also different between one merchant to another. Sortable, same thing. Although LiveSearch provide a default to sort by name, relevance, price, right, which are very common in e-commerce, but certain merchant may want to sort by a different attribute. Like a wine merchant may want to sort by appellation, while a car parts merchant may want to sort by SKU. A beer merchant may want to sort by ABV, alcohol by volume. So that hopefully gives you a little bit of background on how the index may be different between one merchant and another. And remember that LiveSearch is a multi-tenant SaaS product. So we have to accommodate all of this type of indices and merchants. The next slide here, LiveSearch document structure. This shows how a document is being stored in, a document may represent a product. So a document here has a different section where it has a required fields. These are the fields that always be indexed. There are conditional attributes, searchable. So during indexation, LiveSearch actually assigns specific index analyzer and search analyzer for faceting. It also aggregates across child products during the indexation. Filter structure, this is a unique combination that involved in a facet search. This also aggregates being aggregated across child products during indexation. Image structure, similarly aggregated across child product during indexation. This allow what you saw earlier for allow LiveSearch to return matching child product image, for example. And there's a other section where we also index other fields for category browse. And I'm going to hand it over to Bill.
Hey, thanks, Charles. Where you see me? Great. So just as background, let's talk about some terminology. And we'll start by talking about store views. And what's important for us is that a store view defines boundary first index. So I don't know how many of you are familiar with Magento, and those of you who are will know that I am extremely oversimplifying what a store view is. But from the search perspective, it really boils down to this is what we need to quantify a single catalog that can be searched at a time. So for example, a store view may be all products in a particular language. You may have a French store view, an English store view, or it might be by geographic area or pricing scheme. It can be anything. It's really up to the merchant. But when you're doing a search, it's always against one store view and therefore against one index. Couple more terms is when we talk about a full index in the coming talk, we're talking about generating an entire index from scratch. So we're taking all the inputs that go into generating that and starting afresh. And that's as opposed to streaming, which is where we already have an index, but something has happened to a product where we need to update the index to reflect a change in the merchant's storefront. So next slide, please. Thanks. So let's talk about why we would need to do a full index. And hopefully this first one is pretty obvious. We have a new merchant. We've signed somebody up. We're highly successful, and we need to bring in their store views so that they can now be searchable using LiveSearch. The other one is you may have an existing merchant who's adding store views. So when they add new store view, that's another event that happens where we have to go in and take all the catalog from that store view and start indexing that so that it can be searchable. In addition to the onboarding scenarios, we also have scenarios where those inputs into the index can change. For example, one of the things that we support is the ability to have synonyms. Like it shows here, if somebody does a search for pants, we allow the merchant to come in through an admin UI and say that that should also correspond to slacks or trousers. And that means that on the back end in Elasticsearch, we need to create a synonyms filter that'll support those translations. And so we need to update our index when that happens. Additionally, we have our product attributes, which are the things that Charles was talking about that go into a document that define what it is that can be searchable. It's not unheard of for us to have merchants that have thousands, possibly, of attributes that define their products. And not all of those are search related. Some may be related to categorization or some internal processing. And if we were to try to index every single attribute that existed in the merchant's catalog, that could easily blow out our space and become very expensive and lead to very time-consuming search results. So we try to keep our index as focused as possible and index only those things that are actually related to search. But that also means that if the merchant adds a new attribute to their product catalog, which is searchable or can be filterable or faceted on in some way, we need to update our index so that we can pull in all their products and add those values to our index so they can be satisfied. So next slide, please. So this kind of busy diagram shows a high-level view of our full backend architecture. Very broadly, you can see the search client on our right that's coming in through Adobe I/O, which is our gateway, and making a request to the search service, which through a lot of things I'm not going to get to here, ends up generating an Elasticsearch query, which ultimately is used to render your search results, and you can see all the relevant results to whatever you typed in. The rest of it is all related to how we keep that index up to date. So to focus this, if we can go to the next bit, you can see we're highlighting this part right here, which is focused on when do I need to do that full indexing. So we have three listeners on, or not listeners, but we have three event sources on top. We have our product metadata, our search admin, and our catalog service. And respectively, those are giving us SNS notifications for when one of those product attributes changes, when our synonyms change in the search admin service, or in the case of catalog export, it's letting us know when a new store view is available. And the ones in green are actually part of catalog service, which is a separate SaaS service that we maintain on the back end, which supports other services as well, such as the aforementioned product recommendations. Search admin in blue in the middle is search specific, and that's used just for us. So those events go to SNS, which we have an SQS listener on, which our dispatcher service is then polling continuously. And when it sees one of those events, it queries a separate service called the meta index service. And what that's doing is that's keeping track of the current state of our indexes as they exist right now. So when we see an event for one of these things, we go and query our meta index and we check, is this something that we care about. For example, is this even a product metadata update that affects search at all? And if so, is it one that affects our index? And if all of those are true, then we go to the next step, which is going to our index writer. So if you go to the next slide, you can see that. And what happens then is the dispatcher has determined that our index is out of date. We need to generate a new one. So we make a call out to catalog export. And what catalog export will do is it will, more efficiently than we can, go and make a dump of that store views catalog to S3. We then take that series of S3 documents and whatever our current product attributes are and our current product synonyms are, and we churn through those to generate a new index. So that's what's happening here. So when we create that new index, like I said, we're taking our inputs, which is our product attribute metadata, our synonyms, and that full catalog export, and we're going through these SQS steps to actually generate the new index. And we're using SQS for scalability and durability, especially as Charles said before, since we're multi-tenant, this gives us the ability to scale out if there's a change that affects a large number of store views, or if we have a single store view that's exceptionally large, we can scale out to get through that faster. So our first step is creating an index, and this is important because when we're doing this full indexing, we're actually doing it into a new index. The existing index is still there and still satisfying customer queries while we're going through this process. So there's never a point where a customer sees a gap while we're going through this process. Our next step is creating an indexing plan, and that's just going through our S3 documents and figuring out how we're going to batch them for processing, which is then done in parallel to those next steps. We're actually indexing those content. So reading those S3 documents, taking our other inputs, and generating those Elasticsearch documents that Charles talked about. These last three steps are that crucial part where we're pausing the indexing. We haven't gotten to it yet, but there's streaming updates going on while we're doing this. We need to pause those because the streaming updates need to now go from writing to the old index to the new index. So this is our little bit of synchronization. We pause that. Once that's done, we swap indexes, and behind the scenes, that's just taking an alias. We have a well-known alias per store view, which was pointing to the old index. We now point it to the new index. We go out to the meta index service. We write out the metadata about our new index, all those inputs that were used to generate it. And then once all that's done, we resume our indexing. And that pause and resume is very fast. It's not even something that the client is going to notice. And when that's done, we're complete. Not shown here is because we're working off a snapshot, we then, once all of this is done, have to go back and replay all the product updates from catalog service that happened while we were doing this process. So that, during the minutes that this was going on, if any products had any name changes or price changes or anything like that, we need to go back and reflect those in the new index too. So next slide. So now let's talk some about streaming. So unlike before, we're talking about things that affect the entire index. Now we're talking about things that affect just a single product or a group of products in that index. So now we're talking about things like going in and changing the name of a product or the description of a product or changing its price. So like we see here, our Sprite foam yoga block, we're changing it to a Sprite foam, I can't say it, foam yoga brick, and we're changing the price from $4 to $5 because inflation, baby. So when people do a search, we need to reflect that, if they type brick, we need to show this product. The last thing that's not really under our control is inventory. So if this thing sells out, there may be some UI elements that we want to show on our search for, this product's currently not in stock or things like that. So we also need to get notified of that. So remember that catalog service is not part of our service. It's another part of our SaaS backend. So it's giving us those SNS notifications. And one of the feeds that it's giving us is every time a product update happens. So we have a listener on our streaming service that's listening for those updates. And as they come in, it can then use another catalog API to get the current state of the product as it exists when we receive that notification, so we can update our index to reflect that. So on our next slide, you'll see our overall architecture again. So now if we click in one more, you can see now we're focusing just on the streaming side on the left. So like I said before, there's a green piece of catalog service called persistent service, sending out those notifications on every product change. We've got our streaming update service listening to those, reading out a meta index service to do some background checks and verify what our current index looks like, and then talking catalog service that can construct those Elasticsearch documents and write them out to Elasticsearch. So next slide, I'll dig into that a little bit deeper. So again, we're getting those SNS notifications. On each notification, we need to do a couple checks. First is we have to do an entitlement check. Those are just updates to the catalog that can be happening for any reason. They're not just for the purpose of consumption by LiveSearch. So first we need to verify, is this even a LiveSearch client? And if it is, we need to go against meta index and check, does this index exist? And like I said before, are we in that critical moment where we're paused because there's a full sync swap going on? If all of those are satisfied, then we generate a document and we update the index. And this is using the exact same logic that we saw in the full index. So given those same inputs of product attributes, synonyms, and such, we're going to generate the same documents into Elasticsearch. And an important note here is that there's no direct coordination between the full indexing and this. It's all managed through managed caches with known TTLs and that meta index service in between. So for example, when we do auto pause indexing, we're not reliant on a message going out to all of our streaming update instances to let them know that it's paused. Our streaming updates will read in from meta index and pause for no amount of time. And the index writer knows that if it just sends out to meta index that this particular store view is now paused, it just has to wait one TTL and it'll know that nobody's writing to that index and that swap can safely take place. So this is kind of our internal SLAs. This isn't really what we're using for our clients. So, but this is more for us to know, like, hey, if we're seeing that a new product is getting created and it's taking more than 15 minutes, we need to set off some alarm bells. There's something to look into. These are very much on the high side because we're a new service and we're still learning where exactly those average boundaries are. The reality is that many of these numbers are much lower than this. Typically measured in minutes or seconds. And usually when it's on the scale of minutes, it's because we're waiting for our catalog itself to get updated, that a product change has happened. So next slide. So as far as scalability goes, our microservices are all running on Adobe Ethos, which is an Adobe managed Kubernetes cluster that we're running on. We get horizontal scaling for all of our LiveSearch instances. So like I was saying before, if we get a sudden run of indexing requests coming in, we can scale out to get through that faster. We can do some Elasticsearch tuning. Like I said, it's still early days, so we're working on that. Right now, the biggest thing we have to watch for on Elasticsearch is that we're just not growing so fast that we're running out of space to add new indexes. So our cluster needs to be sized to our current growth. One thing we may do in the future is split our clusters by size or by merchant profile. For example, if we have a high number of smaller low utilization merchants, we may choose to put them all together on one cluster, whereas we might put some of our high utilization, busy catalog merchants onto separate clusters with less merchants per clusters, or if necessary, even their own solo cluster, Elasticsearch cluster, I should say. Next slide. So future work, like I said, we're still learning where those sweet spots are for scaling. Right now, we're mostly in metric gathering mode, but we're eventually going to have to come back and look for better ways to handle our cluster. We're also looking at a shift from SNS and SQS to using Kafka and an internal Kafka cluster that we use at Adobe called Pipelines. Just something that will help us keep costs under control and give us the better durability, especially as we go multi-region. Which is one of the things that we want to do as well, so that we can get that faster edge routing, so that we're not servicing requests across the globe in a single data center on the West Coast and losing milliseconds doing so. We also may need to look at strategies for mitigating competitive read and write traffic. We're currently small, this isn't an issue now, but we recognize that at some point it may become a problem that our write traffic may slow down our read traffic, and we may need to look at strategies either separating those or looking at other ways to tune our Elasticsearch cluster to handle those better. So I believe that takes us to the end and Q&A. So I will now open up the floor to Q&A to either one of us. It looks like there's no questions in chat right now, but however you best feel free to ask, feel free to do so. And thank you for listening.